This lecture will finish off section 1.1 with conclusions and discuss section 1.2 observations. When scientists make their conclusions, they must take into account all their evidence. And if the conclusion doesn't necessarily have to support the hypothesis, it'll just tell you, yes, I agree with the hypothesis, or no, I need to make a new hypothesis and new experiment and start all over again. As conclusions gather form and as you gain more and more evidence, then theories and laws can form. A theory and a law are not the same. A theory does not eventually become a law. They're both very different. A theory describes why something happens. A law describes or predicts what happens. And oftentimes, a law is mathematical. For example, the relationship between volume and pressure. The theory would say that as the volume decreases, the number of collisions the gas particles make with the wall increase, and this in turn causes more pressure. So, in other words, the pressure increases. The law is mathematical. It's called Boyle's law. And the mathematical formula is P1 times V1 equals P2 times V2. So you can see a theory's mostly words or a sentence, and a law is usually some type of formula. There aren't that many laws in chemistry. We will talk about 5 or so gas laws. Those are probably the most popular laws. You've heard of the law of conservation of mass, and some others last year. But again, laws aren't very common. Okay, on to section 1.1, observation and measurement. Observations obviously are a big part of science. When we do an experiment, we're going to observe. There are two types of observations. The first is a qualitative observation. Qualitative are any kind of this is going to sound redundant, observations related to the experiment. A lot of times they're described as using your senses. For example, smell, so odor would be a qualitative observation. Color, you're using your sight to look at color. Texture, the state of matter that a substance is in. Formation of a solid, a liquid, or a gas. In contrast, a quantitative observation is any observation involving numbers. The other way to say this is a quantitative observation is a measurement. So if something's quantitative, it's a measurement. If it's qualitative, it's an observation. One way I remember this is quantitative sounds a lot like quantity, and you know quantity is related to numbers. So then that can get you to measurement. So quantitative, quantity, quantitative is a measurement. Examples of a quantitative observation would be the mass of an object. Say it weighs 5 grams. The time it took for a reaction to occur. 20 seconds. The volume of a liquid, 100 milliliters. Or the length of a piece of paper, 3 inches. Okay, when we make qualitative observations, often we're talking about color, and a common misconception is the word clear versus colorless. They do not mean the same thing. Clear describes transparency. Okay, so there are 3 ways to describe the transparency. We can say something's clear, we can say it's cloudy, or we can say it's opaque. If something's clear, it's see-through. If something is cloudy, there are parts that are see-through, but it also has a solid cloud in it. Another way to describe it is it's murky. Like muddy water. You can sort of see through it, but it's got this fuzzy cloud type to it. The word opaque means it cannot be seen through at all. Okay, so it's really important. Colorless doesn't describe transparency. Colorless says the color. Clear means something to do with the transparency. So something could be see-through and colorless. For example, water. Water, you can see through it, so it's clear. Water doesn't have a color to it. It's colorless. I want you to take 30 seconds or so and write down the color and the clarity for each of the 3 examples here. Okay, let's check your answers. So for cherry Kool-Aid, the color, we would consider it red. Clarity is clear. You can see through it. Whole milk, the color is white. Clarity would be opaque. And if you're paying good attention, I gave away the answer. Water is colorless and it's clear. So now you know the difference between clear and colorless. Don't call something that has no... So now you know the difference between clear and colorless. Make sure you use the words properly. And again, students often call something clear when they really mean it's colorless. Make sure you write down any questions you have and ask them in class. That's it for today.